So how can there be a part 2 to this? Well, remember, this was the theory or the story of the dead meteorologist. So he ended up messing up his case because he didn't realize that this was ambiguous case of sine law. Remember what we had here, okay? Go back to the example. We had 20 degrees, 25 was the balloon to the meteorologist, 15 was the balloon to the tornado. Okay, so 15 was the balloon to the tornado out here, 25 was out here, and had an angle of, what was it again? 20 degrees. Okay, angle of 20 degrees. But check this out. He based his entire calculation on this. Now, I'm going to show you how the ambiguous case works. This is going to freak you out. Okay, check it. I'm going to just click on this guy here. And watch this. That's 15 kilometers right there. I'm not going to change the length of it at all. I want you to see something. That's also 15 kilometers. See that? That was 15 kilometers. To here. Guess what? So is this. This is actually where the tornado is. Bang. He's right here. Right on top of the meteorologist. Remember, the meteorologist was in his little hut here, and he couldn't see out his window. And he didn't see that the tornado was sitting right there. Bye-bye. The tornado was right on top of him. So let's figure out how to calculate this, okay? First things first. Amazing thing that happens here is you're going to, again, use the sine law with this. So this is going to be the sine of 20 degrees with 15 again, but now check this out. You're going to have to do something else here. You're going to have to figure out this angle here to go with this guy just to find out this distance. Let me clean some stuff up. Let me get rid of all of this garbage again. Start afresh from over here, okay? There's our 15 kilometers. I'm even going to get rid of the tornado. Tornado's gone now, okay? Boom, okay? I'm going to tell you, there's 15, right? That was 25. This is 20. I'm going to pick up this line here, okay? I'm going to bring them over to here, okay? Noting that that is still 15. That's still this guy right there. Haven't changed anything, right? Do you remember what the angle was out here that we calculated? Well, we calculated in the other question. Let's go back to the other question and figure out what that angle was. That's the angle to the tornado. That was 34.75 degrees. Okay, I'm going to use that again. That's 34.75 degrees. Now, why can I use this again? Because this makes an isosceles triangle, which means that this is 34.75 degrees as well. Aha! Those are the same lengths. Isosceles triangles means this angle and this angle are the same. Now, my question then is, wonder what this angle would be. Why would I need this angle? Because this angle and that side go together. Well, easy peasy. That's a straight line. That's a straight line of 180 degrees. I've gone 34. I wonder what's left, right? So I can go into my calculator now, go 180, subtract this 34.75, and get this angle here. Okay, let's figure that out. 180 subtract 34.75. We'll bring up the calculator. Well, 180 subtract 34.75. Well, wait a second. It's all the way up here. 34.75. Let's use the exact value. I'm going to just go and I'm going to do this. I'm going to go and mouse up. And I'm going to take my 34.75 right there, hit enter. Now I know I'm dealing with some really nice decimals. Hit enter, and I find that to be 145.24 degrees. So that's 145.24. Now, that will go with this. This goes obviously with the 15, but wait a second. I don't want any of those numbers. I want this guy to go with the actual length that I want to find, where the tornado is to the meteorologist. Well, how do I find that? You got 20 degrees here, you got the 145 here, add them together, subtract from 180, so it'd be the 180, subtract those two values again, 20 degrees plus the 145 that we had earlier, right, will give me this angle, then I can finish off this sine question. Okay, check it. Now, I'm going to go over here, and I'm going to use my calculator and go, okay, 180, subtract, bracket, remember original angle was 20 degrees, okay, 20 degrees plus this angle that we figured out here, boom, which works out to be a whole rockin' 14.75 degrees. So that means this angle up here, right here, 14.75, and that's going to help us find this distance. So watch. Sine of 20 goes with 15. Sine of 20 still goes with the 15 that was there. Sine of 14.75, which I had just determined, now goes with our new distance from our meteorologist to our tornado right there. We do the cross multiply again. 15 times sine of this divided by sine 20. 15 times the sine of this. 15 times the sine, well, the sine is this, right there, 14.75. Okay, perfect. Equals to, now divided by, what was it? Divided by the sine of 20. Okay, divide by the sine of 20. And look what I got. Boom. 11.167, so 11.2 kilometers away. So this meteorologist is sitting right there not knowing that 11.2 kilometers away, here comes this tornado, and obviously, goodbye, your history, because that wonderful little tornado is right on top of you, and you're swinging around the tornado like that little cow is in the picture, okay? That's the coolest thing. So let's look at some stuff about the ambiguous case, which is really, really important to understand. Remember, in an ambiguous case, of the two sides given, locate the shortest side. Okay, that's what we're after. We're locating the shortest side. Rotate things. Solve it using the obtuse triangle. Solve it using this angle here, and you'll be okay. All right? Perfect.